going to organize your information. So this is 8-6. We're going to do 1. Now the first 18 problems are all work problems. And work problems are, the formula is going to be a rate that you work at. The time you work is going to give you the part of the job that you complete. So I'm just going to go rate times time equals part of job. And then I'm just going to set a table up to identify the information that you have, to try to organize the information so that you can figure out an equation from it. So generally every one of the problems are going to have that table. So it says, number 1 says a park has 2 sprinklers that are used to fill a fountain. One sprinkler can fill the fountain in 3 hours, whereas the second sprinkler can fill the fountain in 6 hours. How long will it take to fill the fountain with both sprinklers operating? So you want to try to decide in the problem whether it's telling you, is this saying that the sprinkler can complete the job in the amount of time, like the 3 and 6 hours? So I'm just going to say there's the first sprinkler and second sprinkler. It's about the only way I can differentiate between the two. In the first sprinkler, it says one sprinkler can fill the fountain in 3 hours. Well, that says by itself it can do it in 3 hours. So you can get a rate from that. The rate is 1 over that 3 hours. It can do 1/3 of the job per hour. Now the second one, it says the second sprinkler can fill the fountain in 6 hours. That is a completed job in 6 hours. So its rate is what? 1 over 6. 1/6 of the job in an hour. Now it says, how long will it take to fill the fountain with both sprinklers operating? Well, down here, there's a total. The total, you can sum times up. You cannot sum rates. And you can sum parts of jobs up. And what it's telling you is one job is complete. Filling the fountain is complete. That's what they want. And it says both sprinklers operating. So if X is the time both operate, then the first sprinkler goes X amount of time, and the second sprinkler goes X amount of time. And the part of the job that's completed by the first sprinkler doing X hours is X over 3, right? You multiply X times 1/3. And the second sprinkler, it'll do X over 6. Now then you can see that if you add these two together, you'll get the job done. So it's X over 3 plus X over 6 is going to equal one job. And that's your equation. So by organizing the information, you can figure out what the equation would be. Now then we just solve this equation. In this equation, we solve it by multiplying everything by the least common denominator, which is 6. Well, 6 times X over 3 is 2X. 6 times X over 6 is X. And then this is times. That's 6. So 3X equals 6. X equals 2. And that's hours to fill fountain when both sprinklers are operating. So that's, now all of these 18 are going to have that same formula. It's going to be rate times time equals part of the job. So you can organize your data into that table if you want to do it in the manner in which I'm suggesting. So 3. And like I say, if you have a different way and you can organize in a different way, I can follow whatever you do to try to figure it out, because I've seen a lot of different ways of doing things. So. But this is, I think, a good way. One person with a skid loader requires 12 hours to remove a large quantity of earth. A second larger skid loader can remove the same amount of earth in 4 hours. How long will it take to remove the earth when both skid loaders are working? So I'll just say the smaller one here, and this is the larger one. Now, it says the person requires 12 hours to remove the quantity of earth. So the job is to remove the quantity of earth, and the small loader does it in 12 hours if it works alone, so its rate is what? 1 over 12. 1/12. It does 1/12 of the job per hour. That's what you're actually saying. And then the larger one does the whole job in 4 hours, so in 1 hour it does 1/4 of the job. Now it's saying that they want to know X hours to complete when working together. So that tells you that the smaller loader will work X hours and the larger loader will work X hours. And it says they're going to finish the job, so the part of the job that's done in terms of the total is going to be one job. The smaller loader is going to do X over 12. Going to do X over 12. That's the part of the whole job it's going to do. And X over 4 is the part that the larger loader does. So now you can see what? Here's your equation right there. Because time, in terms of the columns, these can add together to get something down here. These can add together to get something down here. You can't add rates, right? So in terms of total, you know, this will, so it's X over 12 plus X over 4 equals one job. Then you multiply by the least common denominator, which is 12. When I distribute that, I have X plus 3X equals 12. So 4X equals 12, and X is going to equal 3 hours when both working. So does that make sense? So 5. One computer can solve a complex prime factoring problem in 75 hours. A second computer can solve the same problem in 50 hours. How long would it take both computers working together to solve the problem? So again, it's a rate times time equals part of job, right? And all it's saying, they're just identifying the first computer and the second computer. Now, you want to think about, are those numbers, is that 75 hours and 50 hours the time that it takes to do the job when the computer works alone? So you read it, one computer can solve a complex factoring problem in 75 hours. So that's saying by itself it can do it in 75 hours. So its rate is what? 1/75th per hour, right? The second computer can do it by itself in 50 hours. So in an hour it can do 1/50th. And it says you want to have the computers working together. So X is the time work together. So each computer is going to work X hours. And it says they're going to complete the job, so this has got to be 1 down here in terms of the total, 1 job. Well, the first computer is going to do X over 75. That's the part of the job it'll do. And X over 50 is the part of the job the second computer does. So you can see what your equation is going to be. X over 75 plus X over 50 is going to equal 1. Now, you want to get the least common denominator. Now, the way I would do this, I would say this is 3 times 25, and this is 2 times 25, because the 25 is common to both of them. And then what you can do is you can say I'm going to multiply both by 3 times 2 times 25. So it's 3 times 2 times 25. So when I multiply this right here by the first one, I'll get 2x, right? Multiply this by the second one, I get 3x equals 2 times 3 times 25. So it's 5x so x is going to equal 2 times 3 times 25 all over 5. The 5 goes into 25 5 times. 2 times 3 is 6 times 5 is 30. So 30 hours when both are working. Okay, any questions so far? It says a small air conditioner can cool a room 5 degrees in 75 minutes. Larger conditioner can cool a room 5 degrees in 50 minutes. How long to take to cool a room 5 degrees with both conditioners working? So this is a rate times time equals part of job. By the way, what is the job that they're doing? What is the job they're doing? Cooling the room 5 degrees, right? So it says there's a smaller and a larger, right? So it's a small and a large one. It says the smaller is the 75 minutes what it takes to do it alone. Yeah, it's 75 minutes to do alone. So what's its rate per minute? 1/75th. It can do it alone in 75, then 1/75th is its rate by itself. The larger one says 50 minutes total if it's working by itself, so its rate is 1/50th of the job per hour. Now, they're both cooling, both working, is X. So you're going to have the same amount of time that both are going to work, and it says you're going to complete the job, so there's going to be one job completed. So this says X over 75 is what the small one does. X over 50 is what the larger one does. So what's my equation? Yeah, very good. Equals 1, right? Now this is the same thing. This is as what the previous problem. This is 3 times 25, 2 times 25. The least common denominator is 2 times 3 times 25. And it's 2 times 3 times 25. So when you multiply the least common by the first one, it's going to be 2x. The second one is going to be 3x equals 2 times 3 times 25. So it's 5x equals 2 times 3 times 25. And x is going to be 2 times 3 times 25 over 5. 5. And that's going to be 2 times 3 is 6. 5 is 30 hours when both working. 30 hours to cool the room, 5 degrees when both are working. It says something about that would be both of them working full blast. See, there is an argument that people have. Do you leave this thermostat at a certain temperature continuously, or do you shut it off, let the room warm up, and then cool it down when you want to cool it down? Well, the argument is, see, it takes them working continuously to cool it. If you maintain the coolness, it just fluctuates on and off to maintain the temperature. So which is cheaper? That's what you'd be having to figure out. How much does it have to cool off and on to maintain a temperature versus how much does it cost to cool it down? You know, like if it heats up to 100 degrees and you got to go down to 72, you got to cool it down to 30 degrees. Air conditioner's got to work full blast for how many hours to cool it down? What's the cost doing that versus the cost to keep it at 72 continuously? You understand? That's what, you know, if you had a big building, that would be a big problem, like a building this size. Which is it better? Over the weekend, you know, to maintain the temperature in the building, or like if you're running it for the summer, or let it heat up over the weekend and then cool it down Monday or Sunday night for Monday morning, right? How much energy are you going to have to, how long is it going to take to cool it down? How much energy are you going to have to use? That would be a problem that you would have to work with. So, and, you know, you wouldn't have to be an engineer to do it. You would be a manager of a building, right? Say you decide that you want to be an entrepreneur and you want to own a motel. Do you maintain the temperature of your rooms? Or do you cool them off when people go in? Which is the better way to do it? Which is going to cost you less money? Management decisions. So we're going to have to do this same kind of thing. This says 2 oil pipelines can fill a small tank in 30 minutes. So what is that? What is that saying? Are they working together or are they working separately? They're working together to fill it. It says using one of the pipelines would require 45 minutes to fill the pipe. Is that together or by itself? By itself. So you can get a rate from that one, can't you? That one fills at the rate of what? 1/45th of a minute. 1/45th of the filling the pipe tank in a minute. It says how long would it take the second pipeline alone to fill the tank? So if X is time for second pipe to fill tank alone. And what we have is two pipelines, so the only thing we can do is we can just, it doesn't say bigger or smaller or anything. So this is just the first, and this is the second. So we said we could get a rate for one of them. What was that rate? The one that says 45 minutes working alone. So take your pick. Which one do you want to call it? First pipeline works at a rate of 1/45, right? So for the second pipeline, it takes it X minutes to fill the tank. What's its rate? 1/X, isn't it? It's always, the rate is always 1 over the time that it takes to fill it by itself. The first one can fill it by itself in 45, the second one can fill it by itself in X. So the rate for the first one is 1/45, for the second one is 1/X. Does that make sense? Now it says 2 oil pipelines can fill the small tank in 30 minutes. So that would be the time that each of them are working when they're working together, right? So 30 minutes, and when you run that, what are you going to get? One job done, right? You know what it said? So now you can get that third column finished off and you can get an equation. Do you see that? 30/45, 30/X, and now I got an equation. So I'm just putting the stuff in and then figuring out how am I going to get an equation. Does that make sense? So now my equation that I'm going to solve so that I get the answer is 30/45 plus 30/X gives me one job. Now my least common denominator is what? 45 times X. I multiply both sides by that. When I multiply 45X times 30/45, the 45's go out and I got 30X, right? 45X times 30/X, the X's go out and I have 45 times 30 equals 45X. Now I want to get X's on one side, so I'm going to go to the right and leave my constants. So I got 45 times 30 equals 15, right? So X is going to equal 45 times 30 over 15. You can see the 15 goes into the 30 twice. 2 times 45 is 90. 90 minutes for second pipeline to fill tank. Does that make sense? Okay, 11. says a mason can construct a retaining wall in 10 hours. So what are you thinking? That's the mason doing it by himself, so can you get a rate out of that? How much can he do in an hour if he does the whole job in 10? He can do a tenth of it, right? So that you can get a rate. With the mason's apprentice assisting, the task will take 6 hours. So what is that 6 hours? When they're working together, right? So how long would it take the apprentice working alone? So if you want to, you can say X is the time apprentice can do job when working alone, right? Rate times time equals part of job. That could get annoying after a while, couldn't it? So this is the mason, and this is the apprentice. So is there a rate for the mason? It says the mason can construct the retaining wall in 10 hours. 1 over 10, right? What would be the rate for the apprentice? He can do it in X hours, so his rate would be 1 over X, right? Now it says, with mason's apprentice assisting, the task takes 6 hours. So what would you do? The time that they work is 6 hours each, isn't it? And it says, do they get the job done? They get the job done, right? So now, how are you going to get an equation? Multiply this times this, right? 6 over 10. If you want to reduce that down, you could say that's 3 over 5, isn't it? And then you multiply 6 times 1 over x, 6 over x. And you have your equation you can solve, right? So you have the 3/5 plus 6 over x is going to get the job. You think you could set it up? I mean, I think now it's just simplifying this equation, right? Multiply both sides by the least common denominator. So 5x times 3 over 5 is 3x. 5x times 6 over x is 5 times 6, isn't it? Equals 5x. I'm going to move the 3x over to the right, so it's 5 times 6 equals 2x. So x is going to equal 5 times 6 over 2. The 2 goes into the 6 3 times. So it should be 9 hours to complete job if apprentice works alone, right? Okay. 13. One computer technician can wire a modem in 4 hours. So what's the job? Wiring the modem, isn't it? Sounds like so far. Whereas it takes 6 hours for the second technician to do the same job. You can get rates from that information, can't you? The first technician, if he can do it in 4 hours, what's his rate? 1/4 per hour, right? Second one, if he can do the job in 6 hours, his rate is 1/6 per hour. After working alone for 2 hours, the first technician quit. How long would it take the second technician to complete the wiring job? So X is the time for second tech to complete job. So I got my rate, time, part of job, formula, and the only thing they do is just first and second technician, right? First technician, second technician. Says that first can do it in 4 hours, so his rate is what? 1/4 per hour. Second can do it in 6 hours, so his rate is what? 1/6. It says after working alone for 2 hours, the first technician quits. So the time for the first technician working on the job is 2 hours, right? He's done. Then X is the time that the second technician takes to complete the job, so we got a 1 down there. So what are we going to do to get an equation? Multiply across the top, right? We get 2/4, which is 1/2. That's telling us what? Half the job's done when that technician works. And then X/6 is the next half of the job. What would X/6 have to be? What would the X have to be to make the second one 1/2? 3. So the answer better be 3, otherwise the logic in thinking about it would be wrong. So we can get our equation, our mathematical equation right here. We'll see whether it turns out to be 3. 1/2 plus X/6 has to equal 1 job complete, right? Our common denominator is 6. We multiply 6 times 1/2 is 3. 6 times X/6 is X equals 6. We get X by itself. Do we think 3 is the right answer? 3 hours for second tech to finish job. Now that agrees mathematically with our logic, right? If you have any questions about this, be sure and ask. 15 says 2 welders who work at the same rate welding the girders of a building. So what do we know at the same rate? The amount of hours that they work is the same, right? X to do by themselves. After they work together for 10 hours, one of the welders quits. The second welder requires 20 more hours to complete the welding. Find the time it would take for one welder working alone. So X is the time for each welder to do job alone, right? That's what they're telling us. And this is a rate times time equals part of job problem. So I'm going to organize my data. And all I can say is there's a first welder and a second welder, right? And X is the time they each take to do it alone. So what is their rates alone? 1 over X, isn't it? So the rate for this guy is 1 over X, and same for this, because they both can work at the same rate. Okay, so it says, after they work together for 10 hours. So what is the 10 hours? That's time. And what am I going to put 10 hours in each time slot? Each of them work 10 hours, right? One of the welders quits. So I'm going to have the first one quit. Second welder requires 20 more hours to complete the job. So you add 20 to his time for a total of 30 hours, right? And it says what? The job is complete, so you put 1 right there. Now, how are you going to write the equation that you're going to solve? You're going to multiply across, right? 10 over X, and then you're going to go 30 over X, and you're going to sum down, and that'll give you the equation that you want to solve. 10 over X plus 30 over X is going to give you 1 job. So now the least common denominator is X. So on the left-hand side, it's 10 plus 20, we're at 30. On the right, it's X. So X is 40 hours, and that's for either welder to complete job alone, right? That's what we set X up to be. So that's what it is. That makes sense? You see how that box thing you can get what the equation is going to be that you're going to use. 17. 2 machines that fill cereal boxes work at the same rate. After they work together 7 hours, one machine breaks down, the second machine requires 14 more to finish filling the jobs. So if they work at the same rate, then X by the hours it takes either machine to do job alone, right? We have a rate times time equals part of job. There's 2 machines, so the only difference we can say is the first machine and second. And their rates are going to be what? X is the total amount of time it takes them to fill it each individually by themselves, so each of the rates are 1 over X. Is that right? And it says after they work together for 7 hours, so with the 7, are you going to put time 7 for both of them? Both of them will work 7 hours, right? The second machine requires 14 more when the first machine breaks down. And what, have they finished the job? Yeah, you got 1. So that second machine is going to work a total of 21 hours. So where's your equation at? You multiply across the top, right? 7 over x, 21 over x, and you'll sum that, and there's your equation. So you find the least common denominator, which is x through, you get 7 plus 21 equals x. So x is going to equal 28 hours for each machine to complete job when working alone, right? Okay. So that'll be the work problems, and that's as far as I'll go when we come back on Monday. I'll finish this up on Monday. Then on Wednesday of next week, those word problem 2s are going to be due. And then I'm going to want to have 8. See, this is 8-6. I'm going to want to have 8-5 handed in. Then the following Wednesday, these word problems will be due, and I'll want to have 8-7. You'll get 8-7 next one. And then we'll go into 9 and some of 10.